Hi everyone, welcome back to the Microsoft in 29 days self-paced course and welcome back to GFG practice. So today is the last day for the Microsoft in 29 days self-paced course because today is the day number 29. So today it will be all about mathematics and thank you each one of you for enrolling in this course and watching the videos step by step and also solving the problems. In case if you are new and you have not taken this course, so I will remind you that it is absolutely free of cost and you can find the link of this course in the description of this video. Once you click on the start button after enrolling in this course free of cost, so you will get access to all the 29 days that are there and you'll also get access to the leaderboard because on every day, as you know, I give two problems. I solve two problems as classwork, that is two independent problems. Like you can see, you can find the recordings here as well as on YouTube. Apart from this, we also give three problems we give like as homework, and five, like the other two that are given, they are the classwork problems. So make sure to solve these problems as well, and you can also track your progress on the leaderboard. Now let's discuss a very interesting mathematical problem. Let us discuss the problem container with most water. So the problem says that we have been given n non-negative integers a1, a2 up till an, where each integer represents a coordinate I comma ai, right? N vertical lines are drawn from such that two endpoints of line I is I comma ai and I comma 0. So the find the two lines in between which the maximum water can be stored. So let's quickly discuss the sample test case, right? So if sample test case is given here, so we see sample test case is 1, 5, 4 and 3. Okay. Suppose the sample test case is 1, 5, then 4 and then 3. Okay. So basically this indicates that there will be a tower which will be of height 1. Okay. So there will be a tower which will be of height 1, let's say. Let's say the height 1, if I draw it, so it will seem something like this. There will be a pillar of height 1. Okay. Then after that there will be a pillar of length 5, let's say. So let's quickly draw it like this. After that there will be a pillar of length 4 as well, so let's draw it. All of them will have the same width actually. Then there will be a pillar with height 3. Okay, now what I need to do is I need to tell that which two pillars should I choose, such that the water stored between them is maximum possible. If I see here, so you can easily observe, if I choose this pillar and this pillar, that is the pillar 5 and the pillar 3, suppose if I choose these two pillars, right? If I choose these two pillars, then in that case, what is the distance between the two, right? The distance between the two, like if I see, so these are the heights, so I will write the heights like this inside them. So let's say this is of height 1, this is of height 5, right? This is of height 4, this is of height 3. Then according to index, this is 0 indexed, this is 1 index, this is 2 index, this is 3 index, right? After this, if you see the water stored, so in this, if between 5 and 3, between the pillars with height 5 and height 3, what is the amount of water stored? You can simply see that in this case you will not see this, like you will observe that this is the water amount stored. Okay, this is the amount of water stored. So actually the pillar part will not be considered, but you can see that the amount of water that will be stored will be this much and this much, right? So basically what is the amount of water that is stored? So if I will see here, so what is the height till which the water can be stored? The height till which the water can be stored is nothing but the minimum of the height 3 comma 5. So the height, like height I can say, is what? Height is going to be 3. Okay, now what is the width? The width is nothing but 2. Okay, you can observe like this part and this part, right? Basically, so you can see, so what is the width in which I can store? So width will be nothing but this value. Like suppose this was I, suppose this was j, so it will be nothing but j minus I. So here it will be 3 minus 1, that is nothing but 2 here. Okay, so now if I observe, so how much water amount I'll be storing between the pillars 1, like between the second pillar and the third pillar, which are of height 5 and 3 respectively. So the amount of water that I'll be storing will be nothing but the height into the width, that will be nothing but 3 into 2, so this will be the 6, right? So you can see that for this case the answer is actually 6. Now why is that so? So suppose instead of this, what I was doing was, suppose instead of storing the water between these pillars, if I was doing something else, suppose, right? Suppose they like what I was doing in this case was something different. Suppose if I was storing the waters like this, if I stored the water between this pillar and this pillar, you will say that okay, I should store the water between the leftmost pillar and the rightmost pillar. In that case, I might get the maximum answer. But see, if I store the water like that, so how much water will I store? I'll store some water here, I'll store some water here, I'll store some water here, correct? And in that way, if you will observe, so if this is one, right, so how much water am I able to store? You can see like the amount of water in terms of height. What is the height? So height will be minimum of 1 comma 3. So the height will come out to be nothing but 1. Okay, height will come out to be 1. And if you will observe, so how much amount, like how much is the width? So width is nothing but 3. That is nothing but the index j minus the index I. So that is nothing but the width is 3 minus 0. So that is nothing but 3 here. So if I see what is the area or the amount of water that I have stored, that will be nothing but 1 into 3, and this will give us nothing but 3 only, which is very very less, right, compared to the answer that we were getting 6. So it not only depends on the width, but the answer also depends on the height, because the area is what, like area here will be nothing but the height into the width. Okay, so what are the possible ways for finding the most optimal answer, or finding the maximum water that can be stored? So for finding the maximum water that can be stored, what we can do here is we can maybe think of using a for loop and trying out all the possible pairs, right? What I'm saying is, you try one time. What you do is you fix the first pair, like first pillar, as this the like the index at the index 0. This is the first pillar that is there. You fix your pillar here at as the ith pillar. Then you first of all check this I with this j, right? You check what is the amount of water that can be stored. After that, you move your j here and you check with this I and this j, that okay, what is the amount of water that can be stored between the pillars. Then you move your j here and you check that between this I and this j, what is the amount of water that can be stored. Okay, after this, what you do is you can think of moving your I here, right? I moves here. Then what you do is you start your j from here, like one step ahead, one pillar ahead, and you see what is the amount of water that can be stored between this ith pillar and the jth pillar. Then you move j by one step forward. So now you check between this I and this j, that what is the amount of water that can be stored, right? After this, you will observe that between the pillar 5 and 3, that maximum water can be stored. After this, you move your I here and j here, right? So you check that okay, what is the amount of water that can be stored, and you keep your maximum updated according to that, right? So basically, I'm telling you what? I'm telling you to try all possible combinations. So basically, this means that I will start from 0. I is lesser than the n. I is plus plus. Okay. Then what we will do is initially we'll mark the maximum area as 0. Alright. Then what we will do is we will say that okay, for j starts from I plus 1. Okay. J is gonna be lesser than the n value. Then j plus plus is what we can do. And what will the height? The height will be nothing but the minimum of a of I comma a of j, right? And what will the width? The width will be nothing but j minus I. So I will see what will the area or the amount of water stored, that will be nothing but height into width. Okay, so we can simply say that maximum, will keep a track of maximum. So maximum will be nothing but maximum of mx up till now, the maximum area up till now, comma the area, right? So we can try to find it for all possible pairs. But if we do it this way, so the first outer loop will take order of n time, the inner loop will take order of n time for one traversal. So for like overall time complexity for this approach will be nothing but order of n square, which is quite high. Okay, and can we optimize this further? Yes, we can optimize it. That's why this problem is mathematical in nature, because we need to think more optimally, right? We need to, like, if we see n square, so why are we getting n square time complexity? Because we are trying out all the possible combinations. But do we actually need to try out, or do we need to compare all possible like combinations? No, we don't. Why? Because what you can do is you can think of solving it using 2 pointers. So suppose you will thought initially, what you will think initially, any person will think that let's like initially any person will think that okay, let's put one of the pointers I at the leftmost pillar and put another pointer j on the rightmost pillar, right? And you keep on iterating until I is lesser than j, until the I and j collide with each other, because you cannot have the same pillar, right? So while I is lesser than j, till that point of time you keep on moving, okay, until they have collided. So what you do is, while I is lesser than j, till that point of time you keep on moving. Okay, now what you do is you find the area, right? So actually the area will be what, like the height will be nothing but the minimum of a of I comma a of j, correct? And the width will be nothing but the j minus I. And after that you can update. So mx is equal to maximum of mx comma the area will be what, height into the width, correct? So we'll update it with the height into the width. Or you can say that we can first of all store the area like this, and then we can update. So basically we can say what, we can say that area will be equivalent to height into the width, and then the maximum will be nothing but maximum will keep a track of the maximum area. So maximum will be a maximum of mx comma the current area or the current amount. Correct. This is what we can do. But we also need to shift the pointers, right? Because we need to try out for other possibilities as well. So which pointer should I optimally move? Because if you will see one thing, right? The answer depends on what? Like the answer is nothing but j minus the area for any particular in there, like any pointer, particular pointer I and j, right? And the area is nothing but j minus I into the minimum of a of I, comma a of j. So in this case, I can observe that if I keep on putting, like if I either keep I plus plus or if I keep j plus plus, so they both will come inside. When they come close to each other, then this factor j minus I is going to decrease for sure. But is that the only thing? Because if you will observe, right, so which pointer should I move? You should think, like, should I move my I pointer here or should I move my j pointer here? Basically, you know the answer, that the answer is pillar 5 and the pillar 3, correct? That is one point. But why? Why is that so? The reason for that is very, very simple. The reason for that is, suppose that what I do is, I do one thing. Like suppose that I keep my I there only, right? Like suppose that, like in this case, you can observe that a of I is lesser than a of j. This will hold true for, this will hold true when a of I is greater than a of j as well. Basically, here I is indicating a small, right? Basically, I'm saying that I is like between I and j, between the comparison between I and j, I is pointing to a smaller pillar, right? Smaller height pillar, and j is pointing here to the higher pillar, right? This things can go vice versa as well. Either I can point to a higher pillar, j can point to a smaller pillar. So the things will be true in that case also. So listen carefully. So what you can observe is, suppose if I am, like if I do I plus plus, like if I do j plus j minus minus, okay. Suppose if I move my j point, okay, if I move my j point, so j pointer will come here. Now you can observe one thing, that j minus I is always going to decrease. So the answer will not be dependent directly on this, right? Because it is going to decrease for either you do j minus I or you do I minus j. The distance is going to decrease, right? That is one thing for sure. So what does the answer depend, right? If you see, so if I have this one height, right? If I have this one height, if I remain with the smaller height, right? That is basically if I was pointing to a smaller value and I remain at I and I leave the higher value, right? I move my j to j minus minus. If I move my j one step backwards in the array, then I am at a loss. Why am I at a loss? Because in that case, if I go with the smaller height, then the answer is always dependent on what? Like as I said, j minus I is always going to decrease. So the main thing that the answer is dependent on is the height, right? Is the height. So height will be what? Minimum of h, like minimum of a of I, comma a of j. In this case, if I'll observe, so I can see what, like see, what are the observations that I can make? Like, can I get the area? So see, if I get the area, so if I see, so now when I move my j to the higher point, like to the higher pillar, because now earlier j was pointing to a pillar with height 3, now it is pointing to a pillar with height 4. But if you see, what is the maximum height till which I can store the water? The height is still 1. That is, the smaller guy is keeping a crack at a fixture, the smaller height. Since I'm at a smaller height, so still I am only able to store either one height or maybe lesser than that, right? Like the smaller pillar, if I remain at the smaller pillar, then I'll actually store either the smaller value, right? Either maybe lesser, like either my height will decrease, the height till which I can store the water, either it will decrease or it will remain the same. It will, if it remains the same, then what happens? J minus I is decreasing, and if it remains the same, then overall the area will decrease, correct? And the height is like this height is never going to increase, right? The height till which I can store the water, if I remain at the smaller guy, then the height is never going to increase, correct? So that's why either I get people, like either I get pillars with the same height, even then I'll be able to store till the smaller pillar height only, right? If I remain at the smaller pillar, or if I get pillar with bigger heights, then also I'll store till the smaller pillar only, till one height only, right? Or maybe two or something, right? After this, one thing that we need to observe is, suppose, like in this case we are at a loss, right? You can understand that we are not getting the maximum answer. But suppose what I did was, suppose instead of moving my j, if I moved my I, right? So you can observe that if I remain at the smaller value, then I'll be at a loss. But what I do is, instead, if I is like, if I'm saying that if the a of I, right, is lesser than a of j, so in that case what I do is I do an I plus plus. Then what will happen? Now you will observe. So now I get a bigger height. Okay, I get a bigger height. Like I standing, suppose I standing at a bigger height. Maybe it can stand at a smaller height as well. But now the chances are better, because if you see, j minus I is going to decrease for sure, right? J minus I is going to decrease. So the answer is still dependent on the height. So if I see here, so if I make a decision of remaining at a bigger height, in that case, the minimum height in this case, either the height can go below 3, that is for sure, right? Either the height can go below the, like either the ith height, the height at which the ith index is standing, it can go less. So in that case, my area will for sure decrease. But do I have opportunities of discovering higher areas, like a higher amount of water stored as well? Yes, because if I remain at this pillar, then still the minimum height will be greater, right? Earlier the minimum height was still 1, right? The minimum height, the maximum height till which I could store water was 1, but here the maximum height till which I can store water is 3. Okay, is 3, which is better than 1, right? Which is better than 1. So if I get someone who is at least the height, having the height 3, or if someone is having the height greater than 3, then I'll be able to store this much amount of water, correct? So that means my height can can either decrease, it can remain, like either it can remain the same. If it decreases, then my area will decrease for sure. But if it increases, right, if suppose that if my height of the ith pillar, suppose if it is bigger than the height of the jth pillar, right? So in that case, I'll be able to store at least this much amount of water. Or if it is even same as j, then in that case, if it is same as j, then obviously the amount of water that I'll be storing will be, like, if this much amount of water, like if at least if it is greater, or if it is equal to, then maybe what I can do is, if the previous ith was smaller, then I can store at least this much amount of water, at least till 3 level I can store now. So if I do the index difference, so 3 minus 1 is nothing but 2, and then I multiply it with the minimum height, maximum height till which I can store the water. So the maximum height will be 3, so the answer would be 6, right? So here I'm getting a better answer. So that's why it's more optimal for us to move, like if I standing at a smaller pillar, right? If I standing at a smaller pillar, so it is better for us to do an I plus plus, because in that case my jth pillar can get a better height, right? My jth pillar can get a pair with a new I, which in which the height can be better, right? In which the height can be better compared to the previous height that I was having, compared to the previous height till which I could store the water. So that's why the answer will increase. And similarly, I need to say that else if it happens that, suppose if j is standing at like if the ith index is standing at a pillar which is of lesser height than the jth pillar, in that case I'll do I plus plus. Else what I will do is, else I will simply do j plus plus. Why? Because if j is standing at a smaller pillar, then I would do j plus plus. So this is the observation for this problem, and this is nothing but a mathematical approach for it. So let's try and write the code for this approach. So what we'll be doing is, first of all, we'll declare long the maximum area initialized as 0. Okay, we'll have the height, we'll have the width as well, and we will declare the array, like let's declare it as a, and let's declare this as n. Okay, after this part, let's say I store the area as well, right? Area or the amount of water. So what I will be doing here is, I will say that, okay, int I starts from 0 and j starts from n minus 1, that is from the end, right? And while the I is lesser than j. Now since we are using two pointer approach here, so like at most how much we are traversing, right? In the worst case, like I will be moving from here to here, j will be moving from here to here. So in the worst case, the number of indexes that I'll be covering will be nothing but order of n only, right? So I will do what? First of all, I'll find the width. So width will be nothing but what? Width will be nothing but j minus I. Okay. Then what will the height? The height will be nothing but it will be the minimum of the maximum height till which I can store water will be minimum of a of I comma a of j. After this, what we will do is we'll find the area. So area will be nothing but width into the height. Okay, and then I will say that, I'll compare the maximum area. So mx is equal to nothing but the maximum of mx, the maximum area I found up till now, comma the current area, right? And then I'll move the pointers. So if a of I is lesser than a of j, in that case, if ith pillar is of smaller length, then I'll do an I plus plus, because I'll try to maybe move to a better pillar, right? With a better height. And then else what I'll do is I'll do j minus minus. Okay, so whichever index is small, standing at a smaller pillar, that index I'll increment or decrement depending on the case. And in the end, my maximum area will be stored, so I'll return the maximum simply. Let's try and compile this code to see if there is any error in this code or not. So it gives the answer as 6. Let's try and to submit this code as well. So you can see that our solution was able to pass all the test cases. If you understood this problem, make sure to hit the like button, comment down understood as well. Thank you. In this video, we will discuss the problem trailing zeros in a factorial. The problem says that we have been given an integer n and we need to find the number of trailing zeros in n factorial. So first of all, what is trailing zero, right? Suppose I have a number, suppose the number looks like 8, 7, 5, 2, 4, 0 and 0. So here you can see that two zeros are there in the end. So these two zeros are known as trailing zeros. The zeros that I have in the end, that are known as trailing zeros. So here I have two trailing zeros. Suppose it was something like 8, 7, 5, 0, 0, 4, 0, 0, right? So in this case also I just have two trailing zeros, correct? Suppose if I talk about 5 factorial, so as we know that 5 factorial is nothing but 1 into 2 into 3 into 4 into 5, and this is nothing but 120. So how many zeros I have in the end? I have just one zero in the end. So I'll say that number of trailing zeros is just 1 here. Let's try and check the sample. So you can see if n is equal to 1, then the number of trailing zeros is just 1 because the number is 120 and the trailing zero is just the last zero, correct? The internal zeros will not be considered. Now if I talk about n is equal to 4, let's say, so when I talk about something like n is equal to 4, so let's see, if n is equal to 4, in that case what will happen here is, we can observe that the factorial will be 1 into 2 into 3 into 4. So the overall factorial will be 2 cross 3, that is 6, 6, 6 4 is 24. So you can see that in 24 there is no trailing zero. So that's why we will return what? We will return a 0 because there are no trailing zeros in this part. So how can I do this problem? So for this we can observe one part, like how are we getting zeros in the end, right? When we multiply certain numbers, how do we get zeros in the end? We get zeros because of two numbers, right? 0 can be got through 2 into 5. If I do 2 into 5, then I can get what? I can get a 10, correct? So it depends on the 2's and the 5, the number of 2's and the 5 that are multiplying. Like if I see, like if I have 5, so you will say that, okay, 1 into 2 into 3 into 4 into 5, okay? So here you can see that one of the 2's is present and another 5 is present. So this will make a pair. Although 4 also contributes to 2. So total 3 2's are there, right? 3 2's are there and 5, like 1 5 is there, okay? 1 5 is there and 3 is occurring 2, like 2 is occurring 3 times. But actually what I'm taking the minimum out of 2, right? And obviously if I see, so the minimum value will be for 5 only, right? Because if I see this much sequence, so obviously 2 will occur more number of times compared to 5. So whatever the answer is, like 2 into 5, whatever the number of zeros that I'll be making, it will depend on the minimum value, that is 5. Because whatever the number of 5s I have available, for them I will have 2 and they will make a pair of nothing but 10, right? They will make zeros in the end, correct? So let's say if I take an example, let's say if I take an example like 11, okay? So how many trailing zeros I have in 11? So for this, let us identify 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10 into 11, okay? So you can see that one, like you can see 1 2 is contributed here, 1 2 and 1 5 here, then 1 2 and 1 5 here as well, correct? So the number of 5 is what? The number of 5 is 2. So that is why I have what? I have it, like I have the number of trailing zeros as 2, okay? Because I have two pairs of 2 and 5, correct? Now like after this, if suppose instead of this, if the number was let's say 12 instead of 11, if the number was 12, if I wanted to find the 12 factorial, in that case I'll have to multiply 12 as well. Still you can see that the number of pairs still remain the same because this 2 and this 5 and this 2 and this 5, correct? After this if I see, so let's say I had to find for 13 factorial. So 13 factorial will be what? 13 factorial will still have two trailing zeros, right? Because I have only two pairs of 2 and 5, correct? After that, if I have 14 factorial, if I have to find 14 factorial, it will still remain the same, okay? If I have to find 15 factorial, then what happens? If I have to find 15 factorial, so the moment I have to find 15 factorial, so I can say that I'll multiply 15. Now another 5, another multiple of 5 gets added, right? So 15 can be written as 5 into 3. So another 5 is contributed from here, correct? And I can see that one of the 2's can be contributed from this 4, right? So I'll have 3 pairs. So if I see observation, so up till 5, right? Up till 5, or I can say that from 5 till 9, right? From like if I have to find 5 factorial, 6 factorial, 7 factorial, like from 5 factorial till 9 factorial, the number of trailing zeros I was having was just 1, okay? You can observe this part. So that means this is nothing but, like if n is given, so n divided by 5 if I do, So that is like n divided by 5 gives me 1 here, right? If the n value is this, right? If the n value was, let's say, 10 factorial to 14 factorial, in that case I can see that I have two pairs, right? At most two, like at most two pairs are there. So two trailing zeros are there in the end. So that is nothing but n divided by 5 again. If I do, so suppose n value is anything between 10 or 10 to 14, right? Anything like 10, 11, 12, 13 or 14. So if it is any value, so if I divide any value in this range by 5, so I'll get an answer as 2 because two trailing zeros were there. Similarly, if n is equal to let's say 15 factorial till 20, like 19 factorial, in that case I will have n divided by 5 again if I do. So I'll get what? I'll get 3 because actually 3 trailing zeros I'll have in the end, right? But if I observe something more, so let's see if n is equal to, like if n is something between 15 factorial, if I have to find 19 factorial till 24 factorial, so still I will see n divided by 5 will be what? It will give me 4. So this means what? This means that total 4 pairs will be there, correct? This means that total 4 pairs will be like total 4 pairs will be there. That will be like total 4 zeros will be trailing, right? But is this true for all? No, this is not true, because if suppose that if I have a number, let's say if I have to find 26 factorial, okay, if I have to find 26 factorial, then what I would have done is, like, see, 5 is like, I can say that 5, like 5 is there, right? The numbers, which are the numbers that are contributing 5? 5 is contributing 5, 10 is contributing 5, 15 is contributing 5, 20 is contributing another 5, right? And I'm doing what? I'm having 25 as well, right? 25 will be contributing 2 5s. So 1, 2, 3, 4, 5 and 6, because 5, this will be contributing 2 5s, right? So 1, 5, 2 5, 3 5, 4 5, and this will be contributing 2 5. So total 6 5s will be there, right? Total 6 5s are there. And if I do 25 divided by 5, what do I get? I get nothing but 5 only. So total there are 6 trailing zeros in n factorial. Total there are 6 trailing zeros, but I am able to discover only 5. Why? Because I am missing out the trailing zeros, that is 2 trailing zeros are contributed by 25, correct? So in this case, what I have to do is, I have to divide, like, the number of factorials will be nothing but n, it will be nothing but n divided by 5 plus n divided by, where n is this value 26, right? So n is this value 26 if I have to find 26 factorial. So n divided by 25 plus n divided by 5 plus n divided by 25. When I will do that, then I will get what? I will get nothing but this part will be from here I can see 1 5, 2 5, 3 5, 4 5, 5 5s I will get from here, right? Single 5s. Then I can see that 25 is contributing 1 extra 5, right? So if I do 26 divided by 5, what will I get? I'll get 1, correct? So that's how I'll get 6 5s, okay? Similarly, if I was given another number, let's say if the number was 127, right? If it was 127, in that case what I will do is, if the number is, if I have to find 127 factorial, okay, so there are single 5s that are contributed, so single 5s I can calculate using n by 5, okay, plus I have to divide n by 25 as well, because the double 5s will also be there, right, as I discussed, plus like I have to divide n by 125 here as well, right, because I have to get the, like, the 125 will be contributing not 1 5, not 2 5, but there will be a third 5 that will be contributed by 125, right? Because it will contribute 3 trailing zeros. 125 itself, the number 125 itself will contribute 3 trailing zeros, right? Because one trailing zero I have counted using 25, another I have counted using 25, another I have to use count using 125. So that's why this total part will be this, right? So eventually I can say that initially I can take the power as 1, like I can take the power as 5 initially, and I can divide, if the, like, I can divide till the time the number is greater or equal to the power, I can divide the number, like, so the count, like I can say here what, like I can see this part, that if the number is given, so the number of trailing zeros will be nothing but n divided by 5 plus n divided by 25 plus n divided by 125 and so on, right, in the multiples of 5. So I can initially mark a power as 5, right, and then I can run that while. I can also mark a count initially as 0, okay. After this, while the number is greater or equal to the power, right, till that point of time I'll keep on iterating, and what I will do is I'll say that the count plus is equal to nothing but the number divided by the power, correct, number divided by 5, then number divided by 125 and so on, up till the number is not like up till the time the number is greater or equal to power till that point of time, correct? And I'll keep on multiplying the power into power is equal to power into 5, so that I can get 125. I can divide it by 125. Like I can divide it by 5 first of all to find the single fives, then I can divide it by 25, so I can find the second 5, and I can divide it by 125 to find the third contributing 5. Okay, then I will return what? In the end I will simply return nothing but the count. Now if I you would have said that, okay, what will the time complexity? So you can observe in this case I'm moving from 5 to 125, like 5 to 25 to 125. So whenever I'm multiplying, like whenever I'm multiplying the number, like whenever the number is greater than 0, and I keep on multiplying it with itself, and that's how I'm moving 5 to 25 then 125. So in those cases the time complexity is nothing but logarithmic of n to the base k, and k value here is 5. So the time complexity for this approach will be order of n log log n to the base 5. Okay, now you will say that why did not we directly find the factorial and then we do it? Because if suppose the n value is very large, then it can go like in if n value is large, and if I find, suppose I have to find the factorial of 10 to the power 8, so it will be very very large, right? Because factorial of 6 is 720, factorial of 5 is 120, right? So which is very very large. If I go for all like more larger numbers, so in that case it will overflow. Neither my integer nor my long data type will be able to handle it. So for that I need to count it using this way smartly, and this approach is also space efficient as well as time efficient, because it takes a logarithmic of n time, whereas the other approach will give us an overflow as well as take a time of order of n, because I'll be multiplying 1 into 2 into 3 up till n, right? So what I will be doing here is I'll simply say that I can mark the power as 5. Okay, then I can mark the count as 0, the number of trailing zeros initially as 0. Then I'll keep on moving that while the number while the time the number is greater or equal to the power, till that point of time we'll keep on taking out the count. Okay, so count plus is equal to nothing but the number divided by the power. Okay, after this what we will do is we will multiply the power. So power asterisk is equal to 5, so power will get updated by 5, and after this one by one the count will get updated, and in the end when the power exceeds the number, in that case we can simply return the count from here. Let us try and compile this code to see if it works on the samples or not. So you can see it works on the samples. Let us try and submit our code as well. So you can see that our solution was able to pass all the test cases that were present here, and the time complexity for this approach is logarithmic of n. And why we are not why we are not generating the complete factorial? Because it will overflow. So in case if you understood this explanation, make sure to hit the like button, comment down understood as well, and thank you.